What's up guys, Van here from McMerwe Farms and welcome to part 3 of this 4-part light related video series. In this video I'll be discussing the theory you'll need to know for part 4 when we start building the LEDs onto the heatsinks. I already covered part 1 and 2, which is just a simpler DIY build. You can find them if you click in the top right corner of your screen. Okay, so before I start, this video is intended for novice people who would like to become more advanced in their knowledge about building their own LED lights. I'm going to start with the bare bone basics and explain everything that I know. I want to dumb it down but also be very technical without trying to lose you. I will not be discussing par or per values, as explaining par or per will take about 20 minutes on its own. It is very complex but also the most useful way of getting the perfect light for your aquarium. I posted 2 links in the description with articles to help you better understand these 2 concepts if you want to build the perfect light. In the remainder of this video, I will only be talking about the series setup and not parallel. Series is when the electrical current only follows one route, and parallel is where the current splits into different streams. I don't like parallel because if one LED fails, it might cause the others to overload and fail as well. Now there are other ways to combat this overload, but most of us are perfectly fine only using the series setup. If you want a video where I do a parallel build and explain everything, let me know in the comments down below and I'll see what the interest is. Okay, let's start off by defining some terms, starting with LED, which stands for light emitting diode. This is what the LED looks like, and it's got a positive side and a negative side. When you put electricity through it, it makes light. Next up we have a LED base plate, which is made out of aluminium or aluminum, and it's the place where the LED gets mounted on. If you add the LED onto the base plate, it looks like this and is most likely called a carb or a chip on board. A bunch of LEDs stuck closely together on one base plate will look like one of these, and they will most likely have a higher wattage, but more on that later. Lenses, or as some call it optics, just changes the angle of the light. This can be used to create a more intense or less intense light. Next up we have watt, which is displayed with a capital W. If you want to know the technical definition, 1 joule of energy used in 1 second, and it's basically the work that needs to be done. But I'm not going to confuse you, so just think of it as a unit of consumption and how much the electricity company charges you. So let's work it out. 1000 watt is equal to 1 kilowatt, and 1000 watt used in 60 minutes is a kilowatt an hour. So if you have a 10 watt light, it translates to 0.01 kilowatts an hour that your light will use. So if your 10 watt light is on for 10 hours, you'll be using 0.1 kilowatt total during those 10 hours. If this confuses you, maybe this calculation will help. Take the total watts of the lights that you would like to calculate, divide that by 1000, and then multiply that by how many hours your light will be on for the day. Your answer will give you the total amount of electricity your light or lights has used up during those hours. Now that we understand a bit more about watts, let's look at voltage, displayed with a capital V. Voltage is the difference in charge between the LED's positive side and negative side, or how much voltage does it take to turn the light on. More volts won't fry the LED, that is determined by the amps or the current, which is displayed with a capital letter A. 1000 milliamps is equal to 1 amps. This refers to how bright the LED will shine. To manage the amps and stop the LEDs from blowing out, we need a driver. A driver regulates the power from the wall and changes it so that the LEDs can shine or work properly. And lastly, heatsink. It's the surface area that the LEDs or carbs get mounted on so that the heat that the LED generates can be drawn away from the LED itself. Okay, so how does a heatsink work? When the light is switched on, the LED generates heat and the heatsink absorbs the heat, which you can see here in red. As the heat gets transferred through the heatsink, it gets cooled by the surrounding air. The more surface area, the cooler the heatsink would be, and in turn the LED as well. We get 2 ways in which we can cool a heatsink. Active, which uses a fan to run air over the heatsink to cool it faster, or passive, where we just let the surrounding air cool the heatsink. I don't like active heatsinks because if the fan dies, it most probably will result in overheating and you might blow one of your other LEDs, and the fans also create a bunch of noise. Here you can see a comparison between passive and active surface area needed to cool a 1 watt light. 110 square centimeters is needed for passive cooling and 40 square centimeters is needed for active cooling. This can be used as a guideline for a 1 watt LED, but differences may occur as manufacturers do not all produce the exact same product. Now that you know the individual concepts, let's look at how you choose the individual LEDs to go onto your light. You first have to determine the color you want. You can use Kelvin as a measurement, which will give you a bunch of colors all in one. For an example, a 6500 Kelvin light, which is close to natural sunlight, consists of a bunch of different colors, whether it's blue, green or red, but it will be sufficient for growing the majority of plants in your aquarium. But when we look at individual colors on the other hand, we don't look at Kelvin as a measurement, rather we look at nanometers. Nanometers is the wavelength of light. Plants definitely react better to blue and red light. That's why a plant grow light seems pinkish in color. It's the red and blue combined. So if you're doing a dry start or growing immersed plants, you can add blue, which has a wavelength of 450 to 460 nanometers, and you can add red, which has a wavelength of 620 to 630 nanometers. Keep in mind that red and blue creates more algae in your tank than the regular 6500 Kelvin that is mostly used, so I'll rather stick to the 6500 Kelvin light. Remember that you can mix and match LED colors as long as you keep the amps the same, but more on that later. The second thing we look at when we choose the individual LEDs is their watt. We choose it based on how much light is needed to reach your plants. I want to stand still here for a moment because this is not entirely correct. The biggest question I always get asked is how many watts per gallon or how many watts per liters do I need in my tank? And that's the thing, each tank differs in height, width and length, and each scape differs itself. Some have mountains and some have slopes, some don't. So understanding this is very technical because you have to look at the par and per values, which like I said in the beginning will take me 20 minutes to explain. But I will give you a general rule of thumb of how many watts per liter you'll need for your standard 1 feet, 2 feet or 3 feet tank, which is most likely to be plus minus 30 centimeters deep. Once again, there is no one size fits all approach, but gun to my head, you can use these as a guideline. 0.5 watts per liter is considered as high light, medium light is considered as 0.3 watts, and 0.2 watts per liter is considered as low light. But before using this, please consider reading up on par or per values as I requested earlier. And lastly, you need to look at the amps and the volts that the LED is rated for. It needs to match the driver that you choose. Now that you understand more concepts, let's look at an example of how to pair an LED with a driver. Because when I first started, this is what confused me, and hopefully this example will clarify everything for you. Let's look at amps first. The driver can put out 600 milliamps through to the LED. The LED on the other hand supports up to 700 milliamps. Rule number 1 is the driver must always be the same or less than the LED, otherwise the LED might explode. The amps stay constant and will not decrease or increase when you add or reduce the number of LEDs. Now let's look at volts. You don't have to worry about the input volts of the LED driver, as the driver regulates itself to whatever's the standard in your area. We need to look at the output volts. In this case, it's between 36 volts, which is the minimum, and 65 volts, which is the maximum. The LED on the other hand uses 3.6 volts max. So now you can determine how many LEDs the driver will support. Divide the 65 volts of the driver by the volts of the LED and you will see that this driver will support a maximum of 18 LEDs. You can also calculate the minimum this way by dividing the 64 volts of the driver with the 3.6 volts of the LED, and you'll see it will support a minimum of 12 LEDs. So based on this, you know everything you need to know to continue on to part 4 of this 4-part video series. The problem is that not everyone knows where to find these LED drivers or heatsinks. So if you know, comment down below with your country as well as the shop that you prefer buying these type of products from. If you're in South Africa, you can go to LED Select. I'll post a link in the description below. But before we close this video, here are your 3 tips. Tip number 1. If you can't find cheap heatsinks, you can use aluminium window door frames found at your local DIY store. They sell for half the price because they are not designed for heat dissipation, but for simpler builds they will get the job done at a very low price. Tip number 2. If there's one thing that my wife taught me, it's that friendliness costs you nothing. It might even be lighter on your pocket one day. And tip number 3, remember that actions speak louder than words. Okay guys, that's it for part 3 of this 4-part video series. If this video sucked, you know what to do, but if it was awesome, please get subscribed, press that like button and check out our other videos. I hope you guys learned something today, and as always, keep it shrimple.